The basic idea of integral calculus is finding the area under the curve. Calculus is great for working with infinite things. To find the integral exactly, we can divide the area into infinite rectangles of infinitely small width and sum their areas. Integration is a way of adding slices to the whole. It can be used to find areas, volumes, central points, and many important things. The first rule used is the integral of dx is equals to x plus c. Here the c is the constant. And for the second rule, the integral of x raised to n dx is equals to x raised to n plus 1 over 1 plus c, wherein the n is any real number and it should not be equal to -1. This rule is considered as the power rule of the integral calculus. The third rule is the integral of af of x dx is equals to the integral of f of x dx, wherein a is any constant, and this rule is only used for the functions that only has one term. And lastly, for the fourth rule, the integral of f of x, positive or negative, g of x dx is equals to the integral of f of x dx, positive, negative, the integral of g of x dx. And this rule is used for polynomial functions.
Hi, I am Ayana, and to continue Ms. Jaspreet's discussion, I am going to discuss about getting the indefinite integral or antiderivatives. There are two types of integrals, the indefinite and definite integral. In indefinite integral, there is no limit of integration and there is an arbitrary constant. The integral of f of x dx is equal to capital F of x plus c. On the other hand, the definite integral has limits of integration. The integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where a is the lower limit and b is the upper limit. We have here an example of an indefinite integral. The integral of 6x cubed minus 5x squared plus 2x minus 5 times dx. So let us try getting the antiderivative of this function using the rules discussed by Ms. Jaspreet. The first thing we do is we distribute the integral sign and dx to each term and apply rule number 4, which is the integral of the quantity of f of x plus minus g of x times dx is equal to the integral of f of x dx minus the integral of g of x dx. We first write the integral sign, then each term. The integral of 6x cubed dx minus the integral of 5x squared dx plus the integral of 2x dx minus the integral of 5 dx. Next is to apply rule number 3, which is the integral of a times f of x dx is equal to a times the integral of f of x dx. We pull out the constant of the integral of each term. We first write 6 times the integral of x cubed dx minus 5 times the integral of x squared dx plus 2 times the integral of x dx minus 5 times the integral of dx. Then we get the antiderivative of the integrals of each term, which will be continued by Miss Keisha.
Good day to you all. I am Keisha Renjitika, and I am going to continue what Miss Aliana have started. So the rules we are going to apply in this equation is rule number 2, which is the integral of x of n dx equals x of n plus 1 over n plus 1 plus c. And of course, rule number 1, the integral of dx equals x plus c. This is where Aliana left us off. Now, we are going to apply first rule number 2 in this equation. So, of course, you're going to start with 6 times x to the power of 3 plus 1 over 3 plus 1 minus 5 times, of course, do not forget the equal sign, guys, minus 5 times x squared plus 1 over 2 plus 1 plus 2 times x raised to the power of 1 plus 1 over 1 plus 1. Excuse me. Then this part, in the negative 5 part, we're gonna use the rule number 1. Minus 5x plus c. Always remember plus c, guys. Now we're gonna add the exponents. So 6x to the 4th over 4 minus 5x cubed over 3 plus 2x squared over 2. And we're gonna copy this part. Always remember the c, guys. Now we're going to simplify the equation, the terms. So this is going to be simplified. 3x to the 4th over 2 minus, copy this one because this cannot be simplified, as we know. And this is going to be x squared already. And then copy this part. Plus c. So that is the antiderivative of this equation.